Welcome to class. For our journey today, we'll be looking into the concept of standard forms. Now, standard form is a very important concept as far as mathematics is concerned. You are just trying to see how to write big values, big numbers in their simpler versions, right? So you are taking numbers and converting them into standard forms by finding how many zeros you can shrink or combine or reduce so as to make that number simpler to pronounce, simpler to write, and as well as simpler to solve with. This is what we'll be looking at in this class. For standard forms, we'll look at various numbers that you can simplify. We'll also look at the approximation processes that can be involved as far as these numbers are concerned. These approximation processes would include using the place value. We would also be using the significant figures as well as the decimal places. So let's get to it. Now, for standard forms, our goal is always to rewrite any number we are given in terms of 10 raised to the power n. Now, 10 raised to the power n will refer to how many zeros we are able to shrink that value into. Now, n just refers to the number of zeros in which we have. Now, let's take an example of a number in which we can convert into standard forms. For this digit, we have 570,200, and we are expected to convert this number to standard form. Now, the very first thing to do is identify the position of the decimal point. Now, for standard forms, decimal point is the most important concept. For this value now, this is a complete whole number. The decimal point comes in at the end of this number. So you have the decimal point coming after the last zero here. Now your goal is to convert this digit, this 570,200, into standard form. Now what you have to achieve is to ensure that there is just only one number before the decimal point. Now in this case we have 6 digits before the decimal point. So what you have to do is convert this digit such that there is just one more digit left before the decimal point. Now if you have 6 of this, all you have to do is move this first time, second time, third time, fourth time, and the fifth time. Now if the decimal point comes towards here, it just means that 5 will be the remaining digit before the decimal point. Now you have now successively moved this decimal point 5 times from here: first, second, third, fourth, fifth. So that means that n would be equal to 5. So to convert this to standard form, you would have the digit before the decimal point, then every other digit left, right? Then times this, which refers to how many zeros you have been able to save, which is 10 raised to the power 5, because you were able to move the decimal point 5 times. So n is equal to 5. You have this as 10 raised to the power 5. So we have been able to convert 570,200 into standard form as 5.702 times 10 raised to the power 5. Of course, these last two digits are zeros, and they are the end of the number, so we can write this as 5.702 times 10 raised to the power 5. Let's take another example that explains this concept. Now, we have our second example. We have to convert 0.2347 into standard form. Now, for this case, you have one digit before the decimal point. Yes. However, this digit is the value of 0. Your goal is to ensure that there is one digit before the decimal point, as well as making sure that that digit is non-zero, right? Now, this digit is 0, so it means that we have a choice to move this decimal point forward. We can't move it backwards because on this side there's just the digit 0. So now we have to move it forward towards this angle to make sure that we now have a non-zero digit before the decimal point. Now remember, the goal of standard form is to identify the position of the standard of the decimal point, which is this, and then ensuring there's just one single non-zero digit before the decimal point. So we are going to move this just once to this position. right? We have all these non-zero digits here, but we just need to move it once to ensure that this digit 2 becomes the number, the non-zero digits before the decimal point. So you have this one, you have just moved the decimal point once, and in this case, you'd have this as 2.347 times. Now, you have moved this once, so of course you have n equal to 1. The next thing you have to now identify is, in what direction have you moved this decimal point? In this first example, we moved the decimal point from right to left. So in this case, we moved from right, which is this point, up to this point on the left. That's why we have this as 10 to the power 5. But in this case, we are moving from left to right. Now, when you move from left to right, the value of n becomes negative. When you move from right to left, the value of n becomes positive. This is why this is positive here. But in this case, since we are moving from left to right, the value of n now will become negative. So you have this as 10 raised to the power minus 1. Minus because we moved from left to right. This is a very, very significant difference between these two examples. For this one, we moved from right to left because all these values are whole numbers and the decimal point is here. So we have to achieve one non-zero digit before the decimal point. So we had a positive power here. But in this case, we are moving from left to right because on this side, there is a 0 digit here. So we need one non-zero digit before the decimal point. So we have this as 2.347 times 10 to the power minus 1. Let's take another example. Now we have our third example. We have to convert 3,723.423 to standard form. Now in this case, we have digits, non-zero digits before the decimal point. We also have non-zero digits after the decimal point. So now the question now arises, in what direction would I be moving the decimal point? Remember that our goal is to ensure that there is just one single non-zero digit before the decimal point. If you were to move the decimal point towards the right, then you have a lot of non-zero digits before the decimal point. However, if you were to move the digits towards the left, then you would be able to achieve just one non-zero digit before the decimal point. Remember, that is always your goal, to ensure that that decimal point only has just one non-zero digit before it. So in this case, we'll be moving this decimal point forward, that's from right to left. So we have 1, 2, 3. We stop here. Now we have just one non-zero digit before the decimal point. Now in this case, we have moved this 1, 2, 3. We have moved it 3 times, so you have n equal to 3. The next thing to identify is, have you moved from right to left or from left to right? This was the original position of the decimal point, so we have moved it from this point towards the left. So in this case, it remains positive. Remember, if the decimal point moves towards the right, it's negative. If it moves towards the left, then it's positive. So this is moving towards the left, so it remains positive. So you have this as 3.723423 times 10 raised to the power 3. We have now achieved our goal of having just one single non-zero digit before the decimal point, and this would give us our standard form. Now, you look at all these results and you find out that there are so many digits to work with. We have converted it to standard forms. These are simpler versions of these numbers. However, you still have so many digits to work with. In order to deal with this, we would have to find ways in which we can round off these numbers and ensure that we have smaller number of digits to work with, while still remaining the essence of the original numbers. This leads us to the concept of approximations, which would give us the tool we need to actually simplify these numbers without messing with their original arrangements or their original purposes.